Howdy folks, my name is Paul Czarkowski. I'm a developer advocate at Pivotal Software. In our previous video, I installed PKS and deployed some Kubernetes clusters. In this video, I'm going to show you how to make the Kubernetes masters fully HA and fault tolerant. So as you can see, I have PKS deployed and I have a cluster deployed with multiple Kubernetes masters. Currently, with PKS, you need to create your Google load balancers separately from creating the cluster. I wrote a tool to help with this called GCP-LB tags, which I demoed in the previous video, and I will quickly show it to you right here. When I run this command, it will go and ensure that there's a load balancer set up, and will make sure that the Kubernetes masters are being load balanced. You can see, because I've run this before, it's using the existing resources in Google Cloud and not creating new ones. That's great for a one-time setup. What if I want to monitor my cluster and modify the load balancer anytime a master node is destroyed or created? Well, I can do this quite simply, and I can actually have the Kubernetes cluster monitor itself by adding this as a Kubernetes pod. So you can see here I've got a Kubernetes manifest. It's going to make sure that a replica of my GCP-LB tags image is running at all times. You can see I've added the loop flag to the arguments. That tells GCP-LB tags to continuously run itself in a loop. And you can see I'm passing in my variables as a config map, and I have my Google credentials as a secret. I'm going to go ahead and apply that manifest. And then let's watch the logs and make sure it's doing what it's supposed to do. You can see inside the pod it's already run once, and it's just waiting until it's time to loop again. So that's exactly what we want to see. So now that we have that running, let's look at our BOSH deployment. So here I have a tmux session running, and I'm watching the etcd cluster health on each of my master nodes. And then I have a prompt that I can run BOSH commands. So to make sure this is working, we're going to delete one of our master nodes. First of all, let's get a list of our master nodes, and then let's choose one to delete. Here you can see our command finished. And so let's list our master instances again. And you can see we still have 3, but one of them is brand new. And so that tells us that BOSH saw that we deleted that master node and is remediating it. And so you can see we have a BOSH task, which is doing that remediation. And if we look at that task, we can see that it's working away on getting that VM created and reconfigured. You can also see one of my SSH sessions has terminated, and that's because that server is no longer available. And you can see that my etcd cluster has been degraded. And here you can see that GCP-LB tags has determined that one of the servers is no longer there. So it's removed it from the target pool. So it's no longer going to try to load balance that to the faulty instance. And we're still able to run kubectl commands. So clearly we're still able to communicate with the cluster. So the load balancing is working correctly. Now you can see it's actually noticed that there's a new instance and it's adding that to the target pool. Now we're back up to 3 masters and we're load balancing again. And if you look at our cluster health, you can see that it's now healthy again. That tells us that BOSH has finished creating the master node and our cluster is functioning again correctly. And as you can see, we're still able to run kubectl commands. So in summary, we created a Kubernetes pod to monitor its own load balancers and remediate when master nodes change. We also saw that BOSH and PKS worked together to remediate creating a new VM when a master VM was lost.